So in this question, we've been told that the points A, B and C lie on a straight horizontal road with B between A and C, so that the length AB is 300 meters and the length BC is 200 meters. It then goes on to tell us that a car is traveling with constant acceleration A, it passes the point A with a speed of 5 meters per second, and it travels directly from A to C in 20 seconds. Okay, so there's a lot of information here, and I'm going to make a start with actually getting a good diagram. So let's show this journey and the 3 points of interest. So I'm just going to try and get a diagram, a visual, to help me think about this journey. We know that it's on a straight horizontal road. I'll start with a straight line, and it starts at A, goes through B, ends at C. I'm going to label these distances in between, so 300 meters and 200 meters. Okay, so a good visual of the journey that's being taken. We were told in the preamble that the car has a constant acceleration of A, and it passes the point A with a speed of 5 meters per second and travels directly to C in 20 seconds. So all of this information is about the journey A to C. When I collect my SUVAT variables, I'm considering the journey A to C. So let's go ahead and collect them. So the displacement, the distance traveled, 500 meters. The initial velocity, the velocity at A, is 5. We don't know the final velocity. We know that the acceleration we're going to refer to as A, and we know the time taken is 20 seconds. This is enough information for us to find A. We just need to choose the right formula, the one that includes S, U, A and T. This is the formula. S equals ut plus half at squared. We'll substitute in everything that we know. And the only unknown is the A, the acceleration. So just rearranging and solving should get us an answer for that acceleration. So in this case, the acceleration is 2 meters per second squared. Next, we're asked to calculate the speed of the car at point B. So this isn't the exact same journey. We're not thinking about AC, we're now thinking about AB. But we have more information about this car and the way that it's traveling. We now have that unknown acceleration. Let's collect SUVAT variables again, this time for the journey AB. So the distance or the displacement is only 300 meters. Initial velocity, the velocity at A, is still 5. That remains constant. We're looking for this unknown velocity at B, and we know the acceleration is 2. Okay, choosing the right formula, v squared equals u squared plus 2as. We can substitute our values. I'm just going to square as I go along. On the right hand side, we end up with 1,225. And the square root there is going to be 35. So the velocity when the car is at point B is 35 meters per second. We're also asked to find the time that it actually takes to get from A to B. So I'm still using the same set of SUVAT variables, but now I'm looking for the time. I'm looking for T. So I'm going to choose a formula that involves S, U, A and T, and substitute in. With T being the unknown, this is going to generate a quadratic equation. So let's just be careful with the values that we get for T. Which ones are sensible and which ones can we eliminate? Okay, so just rearranging this into a more familiar form. We should actually be able to factorize this in our heads. And I can see it's 20 and 15. I'm going to go for positive 20, negative 15. And that means I have two solutions. Either T, the time of the journey, is negative 20, or the time of the journey is 15 seconds. The negative wouldn't make any sense in this context. Let's go with time equals 15 seconds. So a nice question here on kinematics, choosing the correct portion of the journey to work with, and as always, choosing the correct formula to substitute our values into.